This lesson covers the various types of storage available to your enterprise. If we look at the most basic type of server, it can have disks internally. So these disks are known as direct attached storage. They are either within the enclosure of the server or they're in an external enclosure that is directly connected to the server. These disks could be IDE, SATA drives, SCSI, SSD. But this is a very simple configuration. The disks belong to this single server, so it's easy to configure, it's easy to set up, and it's relatively inexpensive. You connect the disks into the server through either its internal storage connectors on the motherboard or maybe a storage card. The challenge with this solution, however, is that this storage is now local to that box. It's isolated. You have to consider backing up that storage. You have to consider its actual utilization, because if only that server can see the storage, it's not generally available to other servers unless it's offering some kind of sharing option. Additionally, with direct attached storage, if there is a lot of I/O, then that actual host operating system is using CPU and memory to process those reads and writes, which then takes away resources that maybe it should be using for applications or other types of service. You can see here in this example, this server has a number of direct attached disks. If I actually go into Device Manager, I can actually see those disks are local to this machine. The next type of storage we have is a network attached storage device. So this is a dedicated box that has its own native operating system and a lot of storage connected to it. And its sole purpose is to offer that storage over your existing network. So this is using your existing Ethernet network, is using your existing TCP/IP, and it's offering that storage at a file level. So it's a file-based protocol. So I can access this, for example, via server message block, network file system, NFS. And then those servers that are using that storage connect via one of those protocols and basically see them as shares. For example, I'm connected to a NAS device in my environment, and I can see the various shares that are offered by that NAS device, and I can connect to them and use that storage. Now these NAS devices, because they're connecting really to your existing network, they're not requiring their own special fabric. They're actually generally pretty inexpensive. So they're cheap to implement. They're also generally very easy to configure. They may have a web-based interface, they may have some application. And they're now centralizing that storage. So it's going to give you a higher utilization of that storage, make it simpler to back up, for example. The challenge is, because it is using your existing network, it may clash with the other network traffic you have. Its speed is going to be restricted based on that existing network and the bandwidth available. And also, traditionally, it's not considered an enterprise solution. I wouldn't think, for example, of running my SQL Server databases or Hyper-V virtual machines over SMB because of restrictions in the protocol, how file handles are managed, locks, etc. However, I would say with SMB3, which was newly introduced with Windows Server 2012 and is being adopted by a number of NAS solutions, with SMB3 you can run SQL databases over SMB. You can run Hyper-V virtual machines over SMB. It just has to be SMB 3.0. But traditionally you would see NAS used for file sharing, document storage, etc. And remember, I don't have block level access to these disks. I'm accessing it over a file-based protocol. So I can't see the file system, I just see the files and folders offered by that NAS appliance. The next type of storage is a storage area network. This is considered the top level storage appliance and is giving you the highest levels of functionality in terms of the way it stores data, its high availability options, deduplication, and they would typically have their own fabric to connect from the SAN to the server using that storage, such as iSCSI or Fibre Channel. This means you actually require a dedicated fabric and generally dedicated controllers and cards between the server and the SAN, making it a much more expensive solution, but it is giving you the top level of functionality. It's also typically going to require specialist skills in your organization, whereas a NAS or direct attach can be managed by any general system administrator. Storage area networks, because of their advanced features and therefore complexity, requires specialist SAN skills to actually utilize them. But if you do need the highest levels of performance, a SAN is going to be what you're going to use in your environment. Also, SAN storage is typically used as the backend when we require clustered services. If I require a cluster to have access to shared storage, I'm going to utilize a SAN typically as that backend storage. And the difference between a SAN and a NAS is my machine's using that SAN storage connecting via iSCSI, for example, or Fiber Channel. As you can see here, I'm connected to a iSCSI target. That storage actually appears as a volume, so it's not directly attached, but the protocols being used, I have block level access to that device. So I can actually create my own volumes on it, format the file systems, and really do anything I would do with a direct attached, but without the challenge of having this local to the machine, which then gives me utilization, backup, and other management problems.